Hi everyone, this is Tutor Marife MCP. I create math tutorial videos that could serve as your supplemental learning resources. In this video, I'll be explaining how to work these two problems out using the circle power theorems. In the first figure, we have two intersecting chords inside the circle, while in the second, we have a tangent segment and the secant segment joining at a point outside the circle. In both figures, we need to solve for x. Let's start with problem number 1. This is the given figure. As you can see, we have two intersecting chords inside the circle. Chord LM intersects chord ON at point P. When two chords intersect inside a circle, each chord is divided into two segments, which are called chord segments. Chord LM is divided into chord segments LP and PM, while chord ON is divided into chord segments OP and PN. To solve for x, we are going to apply the Chord Chord Power Theorem. This theorem tells us that the products of the lengths of the chord segments are equal. In other words, the length of chord segment LP times the length of chord segment PM is equal to the length of chord segment OP times the length of chord segment PN. This is our equation. It's an application of the Chord Chord Power Theorem. Replace LP and PM with their given values. LP is equal to 3, PM is equal to 4. Replace OP and PN with their representations. OP is represented by x, PN is represented by 7 minus x. Simplify left side, 3 times 4 is equal to 12. Use distributive property of multiplication on the right side. Distribute x into each of the term inside the parentheses. X times 7 is equal to 7x. X times negative x is equal to negative x squared. We are solving a quadratic equation. Let's collect all the terms on the left side to make the right side 0. And how do we solve a quadratic equation if the leading coefficient is positive 1? By factoring method, focus on the constant term. Our constant term is positive 12. Think of factors of positive 12 that add up to the coefficient of x, which is negative 7. What factors of 12 add up to negative 7? We have negative 4 and negative 3. Let's double check. If we multiply negative 4 and negative 3, it's equal to positive 12. It's the constant term of the quadratic equation. If we add negative 4 and negative 3, the sum is equal to negative 7. And the sum is equal to the numerical coefficient of x of the quadratic equation. Therefore, we can factorize the left side of our quadratic equation as x minus 4 times x minus 3. Equate the factors to 0. Then by zero product principle, we can equate each factor to 0 and solve for x. First factor is x minus 4. Let's equate it to 0 and solve for x. X is equal to, transpose negative 4 to the right, x equals 4. Set the second factor to 0, x minus 3 equals 0. Transpose negative 3 to the right, x is equal to 3. We have two possible answers for x. X equals 4 and x equals 3. Let's validate our answers. We have x equals 4 or x equals 3. If x is equal to 4, the length of chord segment OP is 4, while the length of chord segment PN is 7 minus 4 or 3. If we multiply the two lengths, 4 times 3 is equal to 12. And that product is the same as the product of the lengths of chord segments LP and PM. 3 times 4 is also equal to 12. Therefore, 4 is validated. How about 3? If x is equal to 3, the length of chord segment OP is 3, while the length of chord segment PN is 7 minus 3 or 4. Multiplying the two lengths, 3 times 4 is equal to 12. And that product is equal to the product of the lengths of chord segments LP and PM, which is also equal to 12. Again, we validated the second answer. Therefore, we have two correct answers for number 1. X equals 4 and x equals 3. Here's problem number 2. This is the given figure. Secant segment OP and tangent segment MP intersect at a point outside the circle, at point P. To solve for x, we are going to apply the secant tangent power theorem. This theorem tells us that the product of the measures of the external secant segment and the entire secant segment is equal to the square of the measure of the tangent segment. This is the equation. In other words, this equation follows this pattern: outer portion times whole for the secant segment, outer portion times whole for the tangent segment. For the left side of the equation, let's concentrate on the secant segment. The outer portion of the secant segment is PN. This is what we call the external secant segment. And the whole secant segment is PO, the entire secant segment. For the right side of the equation, let's concentrate on the tangent segment. The outer portion and the whole segment are the same. So PM times PM or PM squared. Okay? So in writing this equation, by application of the secant tangent power theorem, this actually came from this pattern: outer portion times whole equals outer portion times whole. Next, let's replace PN with X. The length of PN is represented as X. And replace PO with the sum of X and 12. By segment addition postulate, if we add up the two shorter segments, it's equal to the whole segment PO. So PO is the same as X plus 12. Let's replace PM with 8. The right side becomes 8 squared. Next, expand left side, use distributive property of multiplication. Distribute x into each of the term inside the parentheses. X times x is equal to x squared. X times 12 is equal to 12x. X squared plus 12x is equal to, evaluate 8 squared, it's equal to 64. We are solving a quadratic equation. Collect all the terms on the left side to make the right side 0. X squared plus 12x, transpose 64 to left side, it becomes negative 64. We now have x squared plus 12x minus 64 equals 0. Again, we are solving a quadratic equation with a leading coefficient of positive 1. By factoring method, let's concentrate on the constant term, which is negative 64. Think of factors of negative 64 that add up to positive 12. It's positive 16 and negative 4. Let's double check. If we multiply positive 16 and negative 4, the product is equal to negative 64, which is the same as our constant term. If we add up positive 16 and negative 4, the sum is equal to positive 12, which is the same as the numerical coefficient of x. Therefore, the factored form of our left side is x plus 16 times x minus 4. Let's equate the factors to 0. And by zero product principle, we can equate each factor to 0 and then solve for x. First factor is x plus 16. Set to 0 and solve for x. X is equal to negative 16. But we are solving for length. Length cannot be negative, so we discard this solution. Equate the second factor to 0, x minus 4 equals 0, and solve for x. Adding 4 to both sides of the equation, we get x equals 4. This is our answer. Let's validate our answer. If x is equal to 4, length of segment PN is equal to 4. And the length of the whole secant is 4 plus 12. 4 plus 12 is equal to 16. Let's multiply the external secant segment and the entire secant segment. 4 times 16 is equal to 64. And that product is equal to the square of 8, which is also 64. Therefore, we validated our answer. X equals 4 is correct. We're done with our two problems. If you have any questions or you want further clarifications, use the comment section. Please don't forget to subscribe to my YouTube channel. I am Tutor Marife MCP. Thank you for watching.